Thank you very much and good afternoon. I want to talk about open source solar technology, and at the beginning I will talk about my motivation, why I am doing it, and how I think that it can work out. But it's at the beginning not so technical, and in the second half it will be more technical. So I hope for everybody it will be interesting. So what I'm planning to do is I want to combine the open source hardware system with some kind of new business ideas, which some people call social business. And by doing this, I will make available kits for small chargers based on photovoltaics. So most people here probably know it, but there are many open source hardware projects, and in principle they work exactly the same as a software project. So you have the same kind of tools, people collaborate, they are connected by internet and so on. There are many examples. The 3D printer is quite famous, and you can see many 3D printers on this side. I worked on something called the Open EEG project, which is about open source brainwave monitoring. And there are also some projects which go in the direction of sustainability and farming and helping to lower the price of such equipment. For example, the live track, the open source tractor, which you can see in the corner. So at the moment, this open source hardware movement is gaining track, and there are people who designed this logo who are working on license and definitions, because it's not so easy as with this GNU license, because the projects, they include hardware, software, construction plans, and so on. So there's a conference about this in the Open Hardware Summit next month. So a typical open hardware project, it's very problem-oriented. You want to make something that solves a problem, and usually it requires some kind of self-assembly. This can reduce the price to about 1/8 of commercial products. So if the ordinary tractor costs 50,000 euro, you can get it for, I don't know, 10,000 euro. And sometimes the savings are much more. So, as I said, there should be some community that can help and troubleshoot to help the people who build it. And one of the most fascinating things about this open hardware is that you have the possibility to learn new technologies, and the learning experience is very important. Because then also if it breaks down, you can fix it yourself because you build it. So it's no problem. Like in all these projects, you have intrinsic motivation from the participants. And now in the open hardware case, very often they are available as kits. So the difference between the software is the self-assembly, the price reduction, but also that you have to pay something to get it. You cannot just download it. And the kit idea, yeah? And why the kits? That's very simple. If you buy like parts for 200 or 400 kits, the price goes down to about half. Yeah? So it makes much sense that one person or one company buys the parts and then just redistributes it. Okay, so the good thing also about the kit, it can give some kind of income for the project and for the people who are involved in the project. And generally, these open hardware projects, they have a built-in price protection. So if somebody would like to sell it for a very high price to make a high profit, it would not work. So that's kind of a safety for the people who contribute, that they don't get, So something bad, the money can also distract you from your main goals, but that's like always the case. So the good thing is you can make it as a sustainable, self-sustainable project, independent project that generates its own funding if you do it right. So if you don't have any cost recovery, that would be like a charity. You just give away your stuff. Yeah? And if you have more than full cost recovery, and you're like a capitalist or somebody who wants to earn a lot of money. But there's also a third way that's called a social business. That's if you do the kind of more than full cost recovery in order to be self-sustainable and to grow the whole thing. So that's what I would like to do. And there's Muhammad Yunus, who has won the Nobel Peace Prize for his microcredit ideas, but he does much more. He kind of made the whole theory about these social businesses, and he has funded many businesses. And I think it works very well together, this idea of him to make the social business and the whole open source hardware idea. So these are like the main points, that the main goal has to be to solve a problem for education, health, technology, access, or environment. And and there should be no investors who get more out than they put in. So I think that works very well together. So here, in a normal company, it's very simple. You have your customers, company, and so on. And in the open source design, you have the design is like an own entity. Yeah. So even you don't really need a company or something. You can just make the design and share it. But you can also have companies who are in it somehow and make these kits. So why we need renewable energies? Well, I think we are on some kind of tipping point. We have the problems of climate change and scarcity of oil and so on. And all this oil problem, it leads also to energy poverty. Yeah? There are like 1.2 billion people in the world who don't have any access to electricity. So these are the kind of people who could benefit most from such small systems. And there's also a health risk associated with using non-electric ways for cooking and lighting and so on. But it's not only in the poorer countries, but also in Europe. For example, in the UK, 24% of the households are paying 10% for their energy. So that's quite a lot. And if energy prices rise, they are also in trouble. And some even get de-energized when their electricity company, when they don't pay the bill, they plug the cable with the electricity company. So, well, this is the oil situation. In the UK, the oil production is going down because they cannot suck out anymore. And the prices go up and down all the time. And this then causes that in the UK, before 2005, they exported oil, and now they have to import it. So it's huge flows of money. So but the good news is that the photovoltaics is picking up very quickly, and after this legislation in Germany was done, you can see that it's like an exponential scale here on the left side, and you can see that it rises very quickly, the amount of production of photovoltaic systems. Okay, so now if you are like on such an island, what would you need first? Yeah? There are already people who work on communications and computers here, but the most important thing is that you actually have some electricity to run all the stuff. Yeah? And that you have some flashlights or some simple lighting system. So I want to concentrate on this first part here. It's maybe not so exciting like rocket science kind of project, but I think it's quite useful also then, because if you have this project, you can use it as a building block for other hardware projects. Okay, so the idea is basically to reduce the costs of such small photovoltaic systems so that they cost maybe 25 euro, including a battery and solar panel and everything. Yeah, and as I said, I want to make it also available in the whole world So people can buy the kits or buy the parts themselves, whatever they prefer, and then they can assemble the thing and sell it locally to start a small business as well. So the idea is very easy. You have the solar panel and you have some device you want to power. This would be the most simplistic solution. And what I want to do is I want to add the light, because many people want light, and the rechargeable battery. Okay? So very easy. So if you really want to get this cost reduction of 1/8, then you have to look at the whole system. You cannot just go to Conrad Electronics and buy stuff. You have to really decide where you can save money. Yeah? And so I looked at the technology that's available, and what most often is failing in these systems is the batteries. After some 1 or 2 years, they are the most weak part in the whole system. So I decided to use only the best batteries that are available. These lithium iron phosphate batteries, they are used in some power tools, and well, they're not so widely available, but they are now interesting also for the electric cars. So there's fast development in this area. And these cells, they actually have a single cell has a voltage of 3.3 volts. So the whole system works on a single cell. So in order to charge it, we need 7 solar cells, and each solar cell has 0.5 volts, about 0.5 volts or 0.6. So together you get 3.5 volts, and you can charge the battery, which has 3.3 volts. And then I'm running an LED. This is a tiny resistor, a small value resistor, but I can nearly directly connect the LED to the rechargeable battery. So for the lighting, I don't even need any switching regulator or so, and I get high efficiency. And for powering something on the USB port, then you need a small switching regulator, which changes the voltage from 3.3 volts to 5 volts, or to 12 volts, depending on what you want to do. So that's how these batteries look like. They are available in different sizes. The smallest one has about 7 watt hours. So the light could go for about 14 hours. And they're bigger ones. You can buy them in all sizes. Okay, that's how a single solar cell looks like. If you buy it, it's just a wafer with some structures on it. And the standard size is 15 times 15 centimeters and about 4 watts. So I brought you some. If you can have a look at it and take a piece if you like, just to get an idea how thin they are. Yeah? And the idea is to make the photovoltaic module, which consists of several of these cells and a glass panel, to make it locally. And that way, the shipping is also much easier. You just have to send very light things around. Okay, so this is how it works. If you have one cell, it has 0.5 volt, 8 amps, 4 watts. If you cut it in half, you have half the amperes, so only 4 amps and 2 watts. And if you put them in series, you double the voltage. So if I put 7 of the big cells, which are like this, in series, I will get 3.5 volt, 8 amps, and about 28 watts if the sun is shining fully on it. Yeah? So it's watt peaks. Of course, if the clouds are there, it will not be so much. And if for the small system, I will just cut one cell into 7 small cells, and then connect them in series, and then I get about 3.5 watts, which is for lighting purpose, for telephone charging and so on. It's completely enough. The problem with the solar panels is that the smaller the panel, the more expensive it is if you break down price per watt. So therefore, if you want to have 5 watt, maybe it will be about 4 euros per watt, so 20 euros, the module itself. Yeah? But the idea is to make it, the whole system, for 25 euros, so obviously we cannot just buy the produced solar panel. But the cells themselves are much cheaper. If you buy them in large quantities, you can get them for below 1 euro per watt. And if you buy broken cells, which have some small flaws or some pieces broken off, they don't look so nice, but they can still be used, and then you get maybe for 30 cents per watt you can get them. So, okay, so that's how you can cut them. You can use such a Dremel kind or a Proxon tool, and you put a diamond-coated, how you say, cutting wheel on it. And then you need something to suck off the dust, because it's probably not good to breathe it in. And that way you can cut them carefully. But it is also possible to buy them in smaller pieces. So if you can buy them in smaller ones, it's easier to do it. And then you can solder them. That's also quite easy. You just have to apply flux, and then on the left side you can see the kind of special wire you put on it. It has the solder already. It's already coated with solder. So that's how you can assemble that. Always one top side to the bottom side of the next one. And that's quite easy. Everybody can do it. It's no problem. But you need a quite strong soldering iron, 40 watt iron. If you have a small one, it will not work so good. Well, the next part is that you have to put it behind something, because otherwise it's too brittle. It has to be protected from the environment. And I'm currently using just two glass plates and some kind of transparent glue in between. And this step, well, it's easy to do it, but it's hard to tell how long this module will last. So there's some more experimentation needed and some verification how to make it really good. Yeah. So this is like the first prototype I made. It has a Atmel X Mega CPU, and the idea behind it was to make digitally controlled DC-DC converters. So you can see that two of them are there. Yeah? The square ones are the coils. And then I wanted to use just 1 or 2 cells, a very low voltage, and switch it up to a higher voltage to charge the battery. But, well, I did some experiments, and then I decided it's too complicated. I want to make it more simple to achieve my goals. So, well, that's how the light is working on the prototype. And this was the first success. I just used the resistor as the load, and when I set the parameters right of the switching regulator, it started to burn. So sometimes, if it's burning, it's good for you, a good sign that it works. So, you cannot see so well, you know. Well, anyhow, this is the next design that I made, and it consists of round circuit boards which can be stacked and which have the same diameter as the battery. So I wanted to stack them on top of the battery so that it's very small system. So on the right side, you can see the DC-DC converter to get 5 volts out of the 3.3 volts to have like a USB charging output. And on the left side, you can see the charging regulator. It has MSP 430 microcontroller on it, and a couple of field effect transistors which can switch on and switch off the solar panel so that it's not overcharged and so on. And well, the microcontroller has a 10-bit analog to digital converter in it, so I can detect the voltage of the solar panel, of the battery, and I can also measure the charge currents, the charging currents. And the good thing is that the microcontroller is very cheap. It's just 50 cents. So, and also there's a very low price development tool for the microcontroller here on the right side. So on the left side you can see how it can be connected for debugging and so on, and programming. So, but I'm still not completely happy with it. Now I want to make the whole thing bigger again, but I want to make it in such a way that everybody can solder it. So the next step is to make it on a circuit board like the launch pad. So I will use like non-surface mounted parts. Okay, and that's why I want to make it bigger. Currently, I'm experimenting with using beverage cans as the case for the system. And I'm using the beverage cans because they have a curvature on the lower side, so I can mount an LED right into this curvature, and then it's kind of like a reflector and a heat sink at the same time. So that's a very good way to make a small light. And then I put a laser cut polyacryl cover on it. Yeah. If you want to look at it, I have some here later after the talk. So I want to fit everything into this can, the small battery, the PCB with the charge controller, and the LED, and then just connect the panel to it. Okay, so here are some places where you can look at the parts that I'm using. Yeah, well, the below $5 development system for the microcontroller. Also, there are some very good instructions how to make the panels on this link, and some information about these lithium-ion batteries. And of course, I'm using as much, I'm almost only open source tools for development. The keycards, schematics and layout, and MSP GCC compiler for the microcontroller. So I'm looking now for collaboration. When the final thing is working, I want to give workshops and maybe visit some hackerspaces and so on. Then I want to work with NGOs, because often they need for their project some solar system and they don't know how to calculate it and so on. And of course, other open source or other projects can use this system and use it as the power supply, like a universal power supply. Also, I have some connections to the Douala Institute of Technology in Cameroon, and they have a really nice place there and electronic workspaces and so on. So I hope that I can go there and test it if it's working there as well. So thank you for your attention, and if you have any questions, please ask them. Don't be shy.
Yeah, if you have questions, please come here to the microphone stand. What? No questions? Oh, there's one.
You spoke about optimizing every component, and gave quite a lot of consideration to the batteries, but so I was quite surprised that you just need to buy random cells from eBay. So the quality of the solar cells is not as important for the quality of the whole system, or?
Sorry, the acoustic is bad. I don't understand.
Hello?
Yes? No, I see.
Now you can hear me?
Yes?
Okay. You talked about optimizing every component and gave a lot of consideration to the batteries. So I was quite surprised that you just seem to buy random cells of eBay. So is the quality of the solar cells itself of no big importance for the quality of the whole system?
Well, I think the main difference is that maybe if you want to make a huge park of big solar panels, every centimeter is important and every % of efficiency. But in my case, I don't really care if I have 3 watts or 3.5 watts. The price is in that case more important. Yeah? Or if I want to make it bigger, I can just make it bigger. Or, yeah, it's no problem. I just make bigger parts.
Okay, thank you.
Are there any questions from the IRC? No? Okay. Oh, got it.
My question goes in a similar direction. It's not about the quality of the cells. Maybe they could be measured. So I don't know how important it is to have similar cells if you put them in series so that they're about equal wattage.
You have to sort them. If you use some kind of broken cells or so, you have to sort them according to power. So otherwise, the weakest cell will determine how much current you can get from the system.
Right.
So if you have one that has 1 amp and the others all have 2 amps, then you only get 1 amp.
And this other question is, you just briefly mentioned it, that you just put it into between two glass sheets.
Yes.
So I think this is also important, how to protect them from the environment so that they would last a long time, because it doesn't make sense if we build such a thing and then after half a year it's broke and you have to build another one.
Yes, that's right. I mean, if the modules are done right, they can last for 20 years or so. But if there's some, I don't know, if the water goes in or something, then of course they can die much faster. So that requires some more research how to make it the best way. Yeah? There are many instructions on there are some instructions on the internet, but that's mostly from people who they just have done it and then they wrote the instructions and they did not do really research how long it will last and so on.
Thank you.
I'm quite interested in building something like this, and
yeah.
I would like to know if you are right now selling kits or in the future will, or and what about, can you approximately say what would be the cost for, well, just charging your smartphone in Northern Europe, in Germany, for example?
Well, no, I cannot really say how much, but somewhere between 25 and 35 euros, I would say it. That's yeah. Maybe obviously I would try to sell them more expensive in Germany, so that I kind of cross-finance the others, which I want to sell more cheaply. But it would be below 50 euro. That's for sure. And the kits are not available yet, but I hope that if I have the next revision, which has the bigger parts, which are easier to solder, then that I can make them available.
Okay, and I have a question from the IRC. WOA is asking, is that kit already selling and where can we buy it?
No, unfortunately not yet, but yeah, check the website and then hopefully in the next half year or so it will be available.
Okay, and someone else is asking on IRC, his name is Shmofu. Do you already have any contacts to the third world?
Yes, I have, like I said, to the Douala Institute of Technology, I have contacts, and I have some contacts to Tanzania, and I think it's not that difficult to get contacts, but I want to have something that I can show them really that's working. I don't want to, expecting me to deliver it tomorrow or so, and then I don't have it yet. So.
Okay, thank you.
So, are there any other questions here? So, I guess this is all. So, thank you, Moritz, for your talk.